So now to close out this section, we're going to look at another example. So in this example, we're given the line, which I'll write right here. It's 2x minus 3y is equal to 9. Notice that this line is in standard form. Alright? And we're given a point. The point is 4 and negative 1. What we want to find is a line that is parallel to it, and also a line that is perpendicular to it. And it has to contain this point over here, which we will label as x1, y1 on top. So we are given a lot of information in this problem, and the key is to use this equation right here to base off our new line. So what I want to do first is go from standard form into slope-intercept form. So we'll begin by doing that. So we have 2x minus 3y is equal to 9. To get it to standard form, to slope-intercept form, we want to isolate y and we want to get it by itself. So we'll begin by subtracting by 2x to both sides. Doing so, we are left with negative 2x plus 9. Now we want y by itself, so we're going to divide everything over by negative 3. Then we're left with 2/3 x minus 3. Now, all we really need is this information over here, the slope. So we'll write that in next to the information that we already know. We know that the slope of this equation is 2/3. And now if you want to find out a line that is parallel to this one, contains this point, what we really have to consider is just the slope, because lines that are parallel to one another have the same slope. And just recall that two lines are parallel if they never intersect. So with this information, we're going to apply the same slope to this given point, and we're going to plug it into point slope form, and then from there we're going to go to slope-intercept form to find the equation of a line that is parallel to this one. And we'll do that in the side. So we know that, before I begin, I'll write down the information that I know, which is point slope form equation, y minus y1 is equal to m times x minus x1. And now we'll proceed to our second step. So we have y minus y1, our y1 is negative 1, is equal to our slope that is parallel to this linear equation, and for it to be parallel we must have the same slope, which is 2/3. Then we have x minus x1, so our x1 is 4. Notice again that we have a subtraction sign followed by a negative number, so we'll proceed by changing the signs. So we have y plus 1. Next, I'll begin by distributing 2/3 over. So I'm going to rewrite this. 2/3 times x gives me 2/3 x minus 2/3 times 4, and I'm going to write this as 4 over 1. Y plus 1 is equal to 2/3 x, and then 2 times 4 gives me 8 over 3. 3 times 1 gives me the 3. Next, we want to isolate our variable, so we're going to subtract by 1. Y is equal to 2/3 x minus 8/3 minus 1 over 1. Yet again, in order to combine these two terms, we must establish a common denominator. The LCD between 3 and 1 is 3. The LCM, sorry. So now we have y is equal to 2/3 x minus 8/3 minus 3 over 3. Now we're able to subtract across. So we have negative 8 minus 3 gives us negative 11, and over 3. So now we figured out a line that is parallel to our previous line. Now next we're asked to find, now that we're given this line and given this point, we want to find a line that is perpendicular. And for a line to be perpendicular, it means that it intersects at a 90-degree angle. So the key thing to this is what we have to do is change the slope in order to find the line that is perpendicular to the one that we're given. So what we do is we must reciprocate our slope and take the opposite. So for example, if we were given a slope that was positive, the opposite would be negative, and if it were negative, it would then be positive. So I will write that over here, slope of perpendicular line, and that's going to be -3/2. So this is the slope that we're going to apply for our next step. So yet again, we're going to apply point slope form. So y minus our y1, which is -1, is equal to our new slope. So slope for our perpendicular line is -3/2 times x minus our x1, which is 4. And all we're going to do is the same process. Yet again, we have a negative sign followed by a subtraction sign followed by a negative number. We'll begin by changing the signs, and we'll proceed to distribute. So we have y plus 1 is equal to -3/2 x. -3/2 times -4. We know a negative times a negative gives us a positive. So we have 3/2 times 4/1. Y plus 1 is equal to -3/2 x. 3 times 4 gives us 12. 2 times 1 gives us 2. Now we can reduce this, so I'll do that in the next line. And 12/2 gives us 6, and we want to get this in slope-intercept form, so we'll begin by subtracting 1 to both sides, and we're left with y is equal to -3/2 x plus 5. Alright, now what we're going to do on the side is graph these so that you can see what it means to be perpendicular and what it means to be parallel. On this line, for this one, we're going to do the parallel line, and on this one, we'll hopefully get the perpendicular line. So we'll label our axis, x and y. Alright, so we'll begin with plotting our first line, and what you got over here. So -3, then we'll apply slope 2, up 2, and then over 3. So we'll get a line that looks just like this. Now, the line that's supposed to be parallel to that, we'll find the y-intercept, which is -11/3, and that's roughly -3 2/3. So that's like right about here. We'll say right about there. Then we're going to go up 2, so 1, 2, and then over 3. Now, my lines aren't as accurate, but you can still see that the idea is still there, where parallel lines will never intersect. Now let's plot the perpendicular line. So we'll plot the first line, which was the y-intercept was -3, and then we'll apply slope over 2, and then and now we'll look at plotting this equation right here. So our y-intercept is 5. 1, 2, 3, 4, 5. Then we'll apply slope. We go down 3. 1, 2, 3, and then over 2. And then see that these intersect, and the angles that are as a result of the intersection are supposed to be 90 degrees, and that's why that's what it means for a line to be perpendicular. And with that sums up this section on using point slope form.